Hey guys, good afternoon. Let's start with our journey of today's class. And today, what we are going to discuss, today we are going to discuss about the Keras framework. Without getting any delay, let's start with our agenda of today. So the agenda of today will be, we are going to understand about what is Keras. And then we are going to see that who has created the Keras and why it is so popular. Then we are going to learn about a Keras model and then how to implement a neural network with the help of this high layer API called Keras. And then finally, we will do some of hands-on. So my main motto here is to make you aware about how to do neural network coding with the help of the Keras. Let's understand this one thing. What is a Keras? What is a Keras? So remember, have you heard about something called TensorFlow or Theano or MXNets? So for creating a neural network, we do the programming into the TensorFlow. We do the programming in the earlier we used to do programming into the Theano. The people into Microsoft, they used to do the programming into the MXNet. They are doing the programming in the MXNet. So doing programming into the TensorFlow is or doing programming into the Theano, it's a bit difficult to do that. It's you have to do a lot, you have to take care of lots and lots of the things. It is not as simple as you might have done for the scikit-learn. Remember, our sklearn is just about create a model like linear regression equal to linear regression function from the scikit-learn and to just do model.fit and extend and access data and your model is completed. What is happening behind the scene is not visible, right? That scikit-learn is taking care of himself, isn't it? Are you guys aware about this? Hope you have some idea about machine learning or deep learning. Then the classes will be more and more um, interactive and more interesting. So you guys know about linear regression, logistic regression, sklearn, and all that. So in that we are just using a function called model.fit, and then we use that xtrain and ytrain, and then all the training of your machine learning, what the machine learning is learning the data, is happening behind the scene, and your sklearn library is taking care of that. But when you do the programming into the TensorFlow, you have to do everything from the scratch. So though the TensorFlow was very popular in research community, for a developer community, they want some high level API. So the Keras came into the picture. So what Keras is doing, the Keras is just created a layer on the top of the TensorFlow or Theano or the MXNet. And whatever the model.fit the sklearn used to do, the same thing Keras is used to do with the help of using the backend of the TensorFlow. So we started that. Okay, our neural network. This is the neural network API, and that is going to run on the TensorFlow, Theano, or the CNTK, right? And then doing the programming in TensorFlow is very easy. That's why because it's a kind of a modular coding. What do you mean by modular coding? So it's like a modular and a sequential coding. So when we do the programming, so we learn that if you wanted to create a layer of a neural network, what you can do, you can just do the stacking. Means you just define one layer, then add one layer, like if you define like model equal to sequential, and then you wanted to add next hidden layer and all those layers, so you can just add on the top of that. So remember how the stack works. Similarly, in that case of the stacking layer will be going to be happen in the Keras. We will going to do that just understand this little bit of theory. More focus we are going to do on the programming part. So just remember this word, that we are going to using the stacking layers now. It's a completely open source, and we have a good amount of documentation. You guys can just type, you guys can just type keras.io. Keras.io is the site. Keras.io is the site where you guys can go and see the documentations. Now, what next? Okay, so it's a high performance API. Means the performance, though it's a high level API, but its performance internally internally it uses the TensorFlow. That is why it's a very performing very fast. Now, who makes the Keras? So, as iSource, it is an open source. So there are a community of the developers, and community of the developers who means right now we have a 4,800 plus contributors who are going to write the codes, and we have like lots of the like more than 2 lakh 50 means 25 millions Keras developers, like person like you and me. When you are going to code into a neural network, most probably they are using Keras, most probably. So the community which uses Keras is a very humongous. We have Microsoft, we have Nvidia, we have AWS, means Amazon, we have a Google. Now Google is doing some of the support. Remember, Google has launched TensorFlow 2.0 I think last year only, last to last year. Yeah, last to last year. And they have tightly coupled this Keras with them. So now working with the TensorFlow 2.x and the version more than 2 TensorFlow 2, it's very easy because the Keras is tightly coupled with TensorFlow 2.x, and that is why it's become so easy to use TensorFlow with the help of the Keras, right? Because Google is behind that. Even Microsoft is using that. Nvidia is the company who creates lots of the GPU. You guys might have heard about GPU if you or one of you are a programmer, sorry, not programmer, gamers. So you guys know about that, what is the use of the graphics card. And right now in deep learning, we are using hell lot of the Nvidia GPUs and AMD GPUs. Mainly 90% of the market is captured by the Nvidia's GPUs. And finally, our giant AWS is also using the same. So if you see what companies are there, what mean the companies, which are the companies who uses this Keras? So you can say it here. We have Netflix, we have Instacart, you have Uber, Google, Nvidia, Expedia, Square. Even in companies like you might have heard about Accenture, you might have heard about this other fintech companies like Morgan Stanley, JP Morgan. All those are going to use that. So who makes this Keras so special? Now you heard about you saw that Keras is very special. Why Keras is special? Because it's make the neural network programming is very easy. If I will show you some code in TensorFlow 1.x, and I show the code in TensorFlow 2.x, and then I will do the same thing into the Keras. Once you see the code into the TensorFlow 1.x, then you will be overwhelmed that my God, who is going to do this much programming? This is the work of any researcher only. But when you learn the Keras, then this Keras is going to make things easy for you, easy for the developers like you and me. So it's a focus on the user experiences. As it's focused on the user experiences, it is largely adopted by the industry, and then multi backend, then very good research community, and all the concepts you can easy to get that. Whatever we have, the keras.io, if you go there, keras.io, the documentation on Keras is very easy. They have a snippet of the code which you can follow along. So now see, so your code can run, your code can run on the CPU as well as on the GPU, and all those things are very easy. These are the 10 characteristics which you only know when you have some of the coding experience. So I'm not going into the more detail, but you know that, but the only crux you can take from that, it's very easy to use rather than using a TensorFlow, TensorFlow or plain Theano. Now see here. So TensorFlow, again the same thing. In slide, we are more and more focusing on that user interface. And the user interface means that this API is designed for the human, not for the machine. Not for the machine. Why? The machine part is taken care by the backend. Backend means what? What Keras is, basically a deep learning, if you see, is all about the mathematical calculations. And I be more precise, it is more about creating, doing the vector calculus. I mean vector uh, matrix multiplication and vector calculus. So what we do, we do lots of the calculation and we do lots of the gradient descent. So is these two things, if you guys, if you are aware about our neural network, heard about that, so you might have heard about these two things. One thing is matrix multiplication, and second thing about gradient descent. So these two thing is done by on the low level, and the stack is done by not the Keras, but the low level of backend, which is a TensorFlow in our case right now. So Keras is highly flexible, multi-platform. Okay, so it can be developed into the Python as well as in R. It can be used with TensorFlow, CNTK, Theano, and MXNet. We can do our code on the CPU, on the NVIDIA GPU, as well as on our AMD GPU. Then new things is come, something called the TPU. What is TPU? TPU, like you guys might have heard about CPU and GPU. What is TPU? TPU is nothing but a tensor processing unit. A tensor processing unit is something called, let's say, if I give you one example. So in that example, if I say 1D array, so 1D array, we can say that 1D tensor, right? 2D array is like a 2D tensor. 3D array is a 3D tensor, and so on. So there are different kind of structure where we will do the specific of CUDA programming, CUDA, CUDA programming, in which you can do directly deal with the TPU cores. If you wanted to experience the TPU, you can go on a Kaggle. You guys have heard about Kaggle, right? Where the all the competitions happens of data science. So you can go on the Kaggle and you can see the environment like GPU, CPU, and TPU. Even might be in our Google Colab. Google Colab will also using this GPU, CPU, and TPU. But for the TPU, you have to do a specific kind of the programming. By default, if you don't do the programming, the code will be going to be detected by the Keras, and if it is if GPU is not there, then it will work on CPU only, and if GPU is present, then it can use the GPU. That is inbuilt in Keras. But when you are going to do the TPU programming, TPU, then you have to do the extensively use of the TPU. So Keras has that facility. Now you can productionalize your model. You can productionalize your model with the help of this. So you have TF serving, you have Teras, JavaScript, you have Android, you have your iOS, and we have this Raspberry Pi also, right? So let's move. So these things are clear, right? That we can do development in Python as well as R, and even we can do the development in JavaScript. We can do the development in other also, and then we can run on the different architecture, and we can productionalize our model like this. Cool. Let's move further. So how it works? So you guys have heard about something called the computational graph. Let me show you something. See here. So see, where suppose I have to calculate this C cross D, right? And this C cross D, where C equal to A plus B and D equal to B plus 1. So generally the human can do it easily, but if I wanted to make it more simplified format, what I will do, I will divide it. I will divide it, and then I will make a computational graph, so that I will first make a node called A, then make a node called B, and then I will do the next operation called C equal to A plus B. So what I did, I created a node B, and calculated C equal to A plus B, and my data has been stored here. Now then what I want, D equal to B plus 1. So in I calculated D here, D equal to B plus 1, where D has been calculated. Now D has been calculated, C has been calculated, D has been calculated. Now then suppose I want to calculate E, so we have to just do E equal to C cross D, and then our already, as we have calculated 2 and 3, then our E equal to C cross D is equal to 6. So this is the internally the computational things works in the Keras, right? We don't need to go that deep here. We mainly focus on the high over high level overview on that. Now, what are the Keras models? Remember, I started with the Keras modeling. So let's say this example. So in this example, what we have taken something called a picture, and that picture I wanted to see, or I wanted to tell that or detect that if this picture is containing a car or not. So how we can create a model, a deep learning model for this thing. So though this example is very overwhelming for right now, because you guys have not understood about what are the different layers, and what are the like here we are talking about convolution, we are talking about max pooling, we are talking about fully connected, we are talking about softmax. So all those things is a part of the syllabus you will be going to learn when you enroll for the class. So here what we have to do, we are starting our code from here. So we do linear stacks of the layer. So first stack, what we do convolution and ReLU. So convolutional layer here, this is the first one. Here is the input. We are giving the input of 24 to 24 multiplied by 224 into 3, means this 224 into 224 is our pixels, means this picture is having this much of pixel, and 3 means it's a color picture, means RGB. So generally all the color picture has been 3 channels called RGB, and it is combination of all those things. So this comes, and on top of that we are going to apply a convolution layer, and on top of that we are going to apply some of the max pooling. Then on top of we all do fully connected layer and all those things. Then so all the things here happen sequentially, and on the layers are put on the top on each other. So it's make a linear stacks of the layer, right? Remember, if I put it here, so you are able to see the output of this input of means input layer, output of go to this convolution, and this convolution output go to this convolution, and so on, right? And then we move, see here. So what we do, we instantiate our model. We first we do import, and after doing the import we do our something called imported our layers. And then what we do, we just instantiate our model. So model has been instantiated at model keras.sequential, and then we are adding. So we are adding one layer, let's say dense layer. Here adding dense layer, here adding dense layer means one on the top of others, the layer has been added, and then how the calculation is going on. So what are those things we will discuss. Don't worry about this. So we have two things. We have something called a functional model, and we have something called a sequential model. So in functional model, what we have, see here. Here we are this code. We are adding one by one. This is a sequential model. And when we do something called a functional coding, functional API, what we do, we just create our input. We created our input. We added X first layer on that. So the whatever the input we are having, we have to put it on, we have to define it here. And then again, this has been stored in X. Then on next layer, again, you have to define it here. Then again, the next layer you have to define it here. So this is a two-way of coding. Either you can do a sequential API or you can do the functional API. Generally, we say that functional model or the sequential model. So this is our sequential model or the sequential API, where we do just create a model, keras.sequential. We instantiate that and we add layers. Here what we do functional coding, means we create a function of that, and we give the input to the next layer of what we are getting from the previous layer. Functional model output, understanding execution. Execution is two type: deferred, think, plan, and execute. Okay, so there are two. This is more about how it's work in internally. So we don't need to understand about more detail on that. But you guys, for the reference purpose, you should know that basically there are two kind of the execution. One is the defer execution, and next one is the eager execution. So by default in TensorFlow, if you are using TensorFlow 2.x, we are using this eager execution. So learning about this defer execution means what? We just create a graph and we calculate the graph. Remember, we have created a graph of creating C equal to C cross D. So same thing what happening in a computational graph, and then once we calculate, we create the graph, we execute the graph at the last. But here what we are doing, here we are doing all the things on the runtime. So basically right now it's only know that we can do the deferred also, but basically right now we are only do the eager execution. So that is very easy to do. So let's implement a neural network. So what we have to do, we have to prepare our input, we have to define our model, we have to use the optimizer, we have to use the loss function, and we have to train. And so these are the five steps. These are the 5 steps where you to train a model or implementing a neural network. So what you do in the first, you create a input in such a format that you can put into a neural network. So this is the first step. You are preparing your input and you have to give the input size. Like your input may be or image, video, text, sound, or the numerical one, right? Then you can define that model architecture, that what kind of the model architecture we have. Like suppose you are working on the ANN or the CNN, means computational, MLP means multi-layer perceptron, CNN means convolutional neural network, and RNN means the recurrent neural network. So for the simple problem, we use called MLP. For the computer vision related problem, we use CNN. For the problem where we have a speech or text data, we use RNN. So all kind of the model, we can define it here in the next step. Then we use the optimizer. What is optimizer? Optimizer, remember I told you something called gradient descents. So gradient descent, this optimizer are the different kind of the gradient descents. What is the purpose of the gradient descent? The purpose of the gradient descent to optimize, to train the neural network so that it converges fast. Now you may ask that what is the meaning of converge fast? Means your model should learn. Your model should learn the relationship between the input and the output, right? So we use optimizer, then we use loss function. What is loss function? Loss function means suppose that you created a model, right? After creating a model, you define a model, you use optimizer, then you got your output, right? Once you got the output, your output is not as expected. Means there is a difference between the expected output and what is the target variable. So what you do, you create a loss, you find it out how much loss we got, and you're trying to minimize the loss, right? Isn't it? Now, so the loss function you define. Now, this loss function depends on that what kind of the problem you are dealing with. Like, suppose if you are dealing a regression problem, then it's a mean square error. Suppose they are dealing with some other problem like uh, cross entropy, means you are using this classification problem, then cross entropy and hinge loss, and then finally train and evaluate models. Let's do some hands-on. So what I will do, I will just take a very basic. I will do the programming in the Keras from the really very from the scratch. So what I have done, I have created one fake regression, means a very toy data set. In that data set, if you're able to see that uh, there is two feature I have given, feature 1 and feature 2, and there is something called a price. Means these two feature are your x variables, and here is the target variable. Means this will be your y, these two are the x1 and x2, right? So let me execute in front of you, right? Now let's do some of the exploratory data analysis. So what I'm doing, I'm just creating a pair plot. You guys are aware about what is pair plot, right? So what it will do, it will going to give you the relation between the graph of relation between these two variables, means the pair of the variable, means the price and feature 2, price and feature 1, price and price. So remember, whenever you got the price over price, you used to get a histogram. You guys are able to recall that if you have done some programming on machine learning. So let's move further. So this is my data, and now what I am doing, I'm using my old friend to do the trend test split, right? So I'm importing from the sklearn model selection, trend test split, and then I'm creating my x and y. So what is x? So x will be, I'm just taking this two, feature 1 and feature 2, and then I'm applying this something called the values. Values means what? Take this data frame, and is whatever the data frame we have, convert into a array, right? So here will be a numpy array, two-dimensional numpy array will be x, and then here y will be the one-dimensional numpy array, right? And once we got these two x and y, then I use my function called trend test split, and by the help of the 30% test size and train size equal to 70%, I do the splitting. So this has been done here. Cool. Now you can verify. You can verify X trend shape, X test shape, Y train, Y text. Cool. So next, now here I'm going to do one more thing. I'm going to normalize this data. And normalizing for what? I'm using this something called the min-max scaler. So before doing any data, before feeding any data to a neural network, you have to normalize the data. why we want to normalize the data, we will discuss in more detail. But first learn what kind of normalization we are going to do. So I'm using this mean mass scalar. What this mean mass scalar will do? So it will going to first it will going to find the standard deviation, right? So the formula of standard deviation is x minus x mean divided by x max minus x mean, and then we convert it into x scaled is equal to standard deviation multiplied by max minus mean plus mean. So this is the formula. This is the formula with the help of I have whatever data I have, I normalize that data. Cool. Let's use the normalization function. So I instantiated this and fit my method on that. Now finally I got a scalar dot transform, x train I got, x text I got. If you want, I can give you some glimpse of this x train. You're able to see the data has been normalized. Now I'm going to remember I told you two things. I told you that we are going to use something called a sequential, and then I will I will tell you to do something called one more thing. Okay, that let's complete this sequential, then I will work that functional API also. So import TensorFlow as a TF, and hold on. Extrain no module called TensorFlow. So what we'll do in this case when you don't have module called TensorFlow, let me install it. So what you do, pip install TensorFlow. Or we can do this entire coding, whatever the coding we have, we can do it from the Google Colab. And Google Colab will be just one step here, Colab. Colab call search. Let's wait, it should work. So what happened here? See what I did. So there is a function in sklearn preprocessing min max scalar. So I took that function. Here, and then I instantiated one of the object of this function, right? Or you can say that class. This class has one object created. Now this object had one method called fit. So I fit that xtrain on that, and then I instantiated xtrain and xtext. Both I do the transform on that. Cool. Got it? Yes, this has been done. Cool. This has been done. So for using that, I have to restart the kernel. Yes. So this thing we can do. Let me comment it out here. Then TensorFlow. Why it's saying again that we import? Okay, forget about that. We don't take that much of tension. We directly go here, and then I will do coding on here. So I'm just uploading the data. Yes, the data is also getting uploaded. Yeah, just wait. So just take a copy of this. And this is the code from google.colab mount a drive. So I have to mount a drive so that I can access this, because this data I have uploaded where? I have uploaded into my this directory. So just execute this code, and then it will ask for some of the things. So I have to give that permission. Let me put the permission, copy, and then yes. Okay, this mounted now. Yes. So everything will be fine now. So let's move further. We understand this pair plot again, text and split, converting this, extrain, normalizing, scalaring. Now here, import TensorFlow worked. Now from TensorFlow Keras.model, you just use this TensorFlow sequential. So guys, this collab is the amazing thing. Whenever you get a problem that you something are not here, something are not there, so you can use this Google Colab. So what is Google Colab? Is you can say that it's a kind of a Jupyter notebook hosted over a Google servers, right? So these things are there on the Google servers, which we are we are freely to use. So here I'm just taking what I have imported something called the TensorFlow.keras model import sequential, and then from model I am importing sequential, but there is layers. So what are the two layers I want? I want layers called dense and activation. So these two things I have imported, dense layer and something called the activation. So let's see what kind of the model we can create. So we can create a model like here, sequential. We can put the model layer 1, layer 2, layer 3, or we can put model like this, layer 1, layer 2, layer 3. Means this one we guys have given the example like model.add, 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 or we can put like this. Now what here I am doing? I am doing here model equal to sequential. Then I'm adding here the four neuron here, four neuron and four neuron, and then I'm adding one neuron on the final prediction, and I'm compiling with the RMS prop, and loss I'm defining as a mean square error. This model has been done. Now understand about the optimizer and loss. So when there is a multi-class problem, what we have to do? Multi-class problem, you can choose the optimizer as a RMS prop or Adam, but your loss should be the categorical loss because it's a classification problem, right? Suppose you have binary classification, you can use loss as a binary cross entropy. And then for the regression problem, your loss will be the MSE. Optimizer, you can choose either RMS prop or the Adam. So this is the basic thing, just a basic thing to understand about what kind of the optimizer and loss you can choose. Make sense, guys? Okay, let's do the training part. So what I'm going to do, see, model has been created here. Now I'm going to use model.fit. Going to train that. So I'm going to train X train plus Y train and epochs equal to 250. What do you mean by the epochs? Epochs mean that how many times my model will going to see the complete data. So 250 times I'm going to run this model, and 250 times it's going to complete X train and Y train my model is going to see. And after each iteration it's going to calculate the loss and try to minimize the loss with the help of what? This optimizer called, what optimizer we have to taken? Optimizer equal to RMS prop and apply the loss equal to MSC. Make sense, guys? What it's happening here? We are creating uh, three layers neural network. On top of that, what we are doing, we are just doing passing all the data points 250 times. And then and then what's happening? The training is happening with the help of the optimizer and the loss function. So let's do that. Let's see. So you are able to see our loss is going to be decreases. Good. So you are able to see we started from a huge loss. We started from, my God, we started from approx loss equal to 22,56,008. This much loss we started, and my model has learned this so quickly that the loss has been decreased to 24. Right? This is the magic of this Keras library and neural network. Now let's do uh, evaluation. So this is all the history. Let's see our loss, and let's make it our training loss. So these are the loss. We started 250 here, and then after, let's say 80, yeah, 80 or 90 epochs, this has been dropped significantly. And after 250, I think more than 250, what I think, yeah, 150 only we able to get, or 100 only we are able to get this the optimal value. Right? Now let's evaluate this. So let's say we have a loss matrix name, and then let's see what is the train score and test score. So our training score is 25, test score is also 25.7. Now let's do further evaluation. So what I did here, I created all the test prediction. So model.predict, and I am giving the X test, right? Remember our text data. And I took all this prediction, and then I created the prediction here, and these are all the values. Now what I'm going to do, I'm creating a prediction called DF. So whatever the data we have, text Y, we created one prediction. So this is my prediction. Now we got our test H and test Y. Now what you want to do, you have to make into a series and text prediction, and then you are going to make a column like this. So this is your test value, this is your test value, and this is my model production. So this is my original Y, and this is my model has been predicted, Y hat. So you're able to see the model is doing the fairly good. So it's a 402, then we have this 404. We have a 605, we have a 622. So mean square error is going to very minimum. So let's plot it. When we plot it, we are approximately we are going to get one straight line. Let's see how many error we have and put the error. So we are able to get this perfect one. Now finally, I'm going to give you that mean absolute error and mean squared error. So these are mean absolute error. We got that. Mean squared error. We got that. Now let's do the prediction with the new data. The final thing what I wanted to do to predict that. So let's understand these three things. What I'm going to create, I'm creating a new data with 998 and 1000. The feature one is 998 and feature two is 1000. Now, as we got data, but my model is only understand that the transformed things, right? So we need to transform with the help of the scalar. So let's do the transform, right? Once we got the transform, we got our new gem. Now, and then model.predict, you are going to use this new gem. So you can predict a answer here. So your answer is 418. So your model is going to predict here. Now, the last thing is this, we can save our model, and again we can use our model. So there is a function in Keras to load model, and model.save is going to save our model into .h5 format on our disk. So just do this, and then we can load this with the help of any load model function, and again predict. So you will able to see this value and whatever the value I'm going to did here will be same. Got it, guys? So what we learn? So we learn here today. Today we learn that what is Keras, and then we learn about that how to do the overall programming with the help of this Keras library and all those things. And we created one very basic model, very basic model we created. So in that basic model, what we created, we created our sequential model, and we created a 3 layer. In each layer we have a 4 neurons, and we have a activation of ReLU activation function we have. And then we use this optimizer called RMS prop and loss of mean square error. Good. And then we train our model for the 250 quarks. Thank you all for joining. Okay, bye bye, see you guys.